Hey boys and girls, it's Miss Escamilla. Congratulations, you have made it to your last day of homework this week. So work super hard, try your best, and then you'll get a nice long 3-day break from homework, from math homework. I know you guys have been working really hard this weekend. I'm very proud of y'all. Today's homework is to finish the packet, which is questions 11 through 14. Question 11 is very similar to a few other problems we've been practicing these last couple of weeks, which is over the concept of plotting decimals on a number line. And so one of the things we've talked about is you'll notice on this number line, I drew one similar to it, that there are 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And the reason why there are 10 equal parts is because, well, it has to do with place value. So for a long time now, you guys have been learning that it takes 10 ones to make 1 10, and it takes 10 tens to make 100, and then it takes 10 hundreds to make 1,000. Well, when you get into your decimal place values, to the right of the decimal point, you have your tenths place. Well, it takes 10 tenths to make 1 1. And if we go over to the hundredths place, well, it would take 10 hundredths to make 1 tenth. So because it takes 10 tenths to make an entire 1 whole, on our number line, well, we have 1 whole, so we need to have 10 tenths on this number line. So starting at 0, that would mean that this would be our first tenth, 1 tenth. Then this point would represent 2 tenths. And then this point would represent 3 tenths, and so on and so forth, all the way until you get to 1 whole. And we know that it takes 10 tenths to make a whole. Okay? So, with that being said, one of the things that you guys also need to remember is that if you have 10 tenths, if you add a 0 to it, you have created, it's still the same number, it still holds the same value. The only difference is now that we would refer to this as 10 hundredths, because that 0 goes all the way to the hundredths place now. And so we would refer to this as 10 hundredths rather than 1 tenth, but they hold the same value. The same thing with 2 tenths. 2 tenths is equivalent to 20 hundredths. And 3 tenths is equivalent to 30 hundredths. So, using that information, I would label the points on my number line and then determine where 63 hundredths would fall on the number line. Okay, so that's number 11. Number 12, I noticed that we have some decimals on here, so that tells me, that's my clue, that we're going to have to be doing some sort, the learning standard is, as a 4th grader, you need to know how to learn to add and subtract whole numbers and decimals. So you have to read carefully to determine whether or not you are going to need to add these numbers or subtract them. But whatever you end up deciding to do, we need to remember that there is a strategy that we use to to add or subtract decimals. Okay, and so I noticed that this number 150 is not in a decimal format. That just means 150 entire whole grams. Whereas this number means 10 and 5 tenths, that means 10 whole grams and 5 tenths of a gram. And then this number right here represents 18 whole grams and 50 hundredths of grams. Okay, so they're all formatted differently. I notice that this number goes to the tenths place. This number is a whole number, and it goes all the way to the hundredths place. And this number is a decimal, and it goes all the way to the hundredths place. So in order to be able to successfully add or subtract these, we need to make sure that they all go to the same place value so that we can line up our numbers correctly. And so, for example, let's say I gave you the number 23, and I gave you the number 8 and 9 tenths, and I gave you the number 1 and 45 hundredths. This is a whole number, this is a decimal, and this is a decimal, and so they're all going to different place values, but we need to make them look uniform in order to be able to add them up. So in order to make that happen, we need to make them all look alike and make them all go through the same decimal place. So because 1 45 hundredths goes all the way to the hundredths place, we want to make sure that we make the other numbers go all the way to the hundredths place before we add them. So for the number 8 9/10, I'm going to put a 0 in the hundredths place, because adding that 0 is not going to change its value. And now it is now 8 90 hundredths. And then this 23 means 23 wholes. But I can add a decimal point and add 2 zeros, and it doesn't change its value at all. However, now I have a number in the tenths place and the hundredths place here, just like I do here and just like I do here, which means we can now add up these numbers a lot easier. So I can add 23 0 hundredths with 8 90 hundredths and 1 45 hundredths. Now I can find that sum by simply adding and regrouping if necessary, like you would normally add. The only difference is that you would need to make sure all your decimals are lined up vertically, and that we go ahead and carry that decimal down so that we don't forget to do that later. So 0 0 and 5 make 5. 0 9 and 4 make 13. I put my 3 here, carry my 1. 8 and 3 and 1 make 13. Put my 3 here, carry my 1. 2 and 1 make 3. So my sum would be 33 35 hundredths. Okay, so I hope that helps you with number 12. All right, on number 13, I noticed that we see some decimals there as well. So that kind of gives me a clue that we're going to need to either add or subtract decimals. So again, you're going to use that same strategy that we did in this problem in number 12. You have to make sure we're lining up those decimals correctly before you carry out the addition or the subtraction. Now, this problem is about the Seattle Space Needle. And what I remember from last year is a lot of kids did not know what that looked like. So I pulled up a picture on Google of the Seattle Space Needle. This is the Space Needle. And so the problem is telling us that the height of the entire needle, the whole entire thing, is 184 41 hundredths meters tall. The whole thing. But the problem also says that the height of the building without the spire. This is the spire up here. Without it, if you were to take it off, the rest of the building is 158 and 12 hundredths meters tall. Okay? So, if we know the length of the height of the entire thing, and we know what the height of this is without that spire on top, just this part right here, what would be the height of the spire? How would we determine the height of this? So we know the whole and we know part, but we don't know this part. So you need to decide what operation you're going to need to use in order to solve that problem. And keeping in mind that we are adding or subtracting decimals. Line up those decimals. And then finally, on the last problem, this is estimating sums of fractions. And this is where you need to know about your benchmark fractions to think about reasonableness. And so this has been a very, very tough skill for us as fourth graders. It's a hard concept to develop. But when you are thinking about these questions, guys, what you need to be thinking about is we want to know which one of these, when you add them up, is going to give you a sum less than one whole. Okay? And so what you need to be thinking about, so for example, if I were to give you, you need to be thinking about if you have 9/10, that means 9 out of 10 objects. Well, that's almost the whole thing. Okay? That's almost an entire whole. So if you were to have an entire whole and add another 3/4 to it, would that be less than 1? And then on the next one, 11/12. Well, that's 11 out of 12 of something. 11 out of 12 is almost the entire 12. So that's almost an entire whole. So if you had almost an entire whole and you added another 5/8, would that give you less than 1? Okay. And then I look over here. That's 2/5. 2 out of 5. So if I have 5 objects, 1, 2, 3, 4, 5, two of them, well, to me, that's less than half. The halfway point would be about here in the middle, right? So 2/5 I know is less than a half. And then I think about 3/7. If I have 3 out of 7 of something, 1, 2, 3, 4, 5, 6, 7, and I circle 3 out of those 7, again, I notice that this 3 is, if this is my halfway point right here, this is the halfway point right here in the middle, again, this is less than a half. So this is less than a half and this is less than a half. So if you combine a less than a half and a less than a half, would you have less than 1 whole? Or do you think the answer is not here? Okay, so you're having to estimate these fractions to get an idea of about how big they are, and adding them together to see if your sum equals less than 1. Okay, it's a difficult concept, but we're just going to keep practicing and getting better and better each time. So thank you for tuning in and watching. Good luck, and I cannot wait to see y'all tomorrow. Bye.